Let's talk about limits at infinity. This sideways looking 8 that's sitting right here is the symbol for infinity. This expression is read, the limit as x approaches infinity of f of x is equal to L. Again, f of x will be a given function. L will be the answer that we seek. This is a description of what these symbols mean. As the value of x gets arbitrarily large, that means x is getting larger and larger and larger and larger, and we symbolize that as x is approaching infinity. The value of f of x should get arbitrarily close to L. L here has to be some finite number. Let's study this with an example. Let's look at the limit as x tends to infinity of 1 over x, and let's see if we can't figure out what this means by using a table of values. So we create a table. On one side we put x, on the other side we'll put this function f of x is equal to 1 over x. And let's first, in this first column of the table, capture the idea that x is tending to infinity. So we should put numbers here that are getting larger and larger and larger, arbitrarily large, for this first column. And so we could use 10, 100, 1,000, 10,000, and this pattern could continue forever. And then we'll compute the corresponding values of f of x and see if we can't see a trend to try to figure out what the corresponding value of L should be. So to find the corresponding value of L, we look at what happens to this trend. Well, we have 0.1, 0.01, 0.001, 0.0001, and it's pretty clear that L is tending to 0, so the answer here is going to be 0. That's a general pattern that's going to happen in problems of these types. If we take the limit as x tends to infinity of 1 over x to the k, as long as k is greater than 0, we're always going to get 0 back. This is a general rule that we can use to help us evaluate limits at infinity, and it's something that you need to remember.